Good evening. A devastating flash flood has struck Nepal. At least 57 people have been reported dead, hundreds remain missing, and roads, bridges, and other infrastructure have been severely damaged. The disaster occurred near the Nepal-Tibet border, and more than 130 Indians were among those reported missing from affected areas. But today's discussion is not simply about another flood, because the available evidence suggests that this may have involved multiple interacting hazards, possibly an earthquake, possibly an ice avalanche or landslide, possibly the temporary blockage of a river, heavy rainfall across the Himalayan region, and then the sudden release of a huge volume of water and debris downstream. So, the real question is, when several hazards interact in the Himalayas, does a relatively small triggering event have the capacity to become a catastrophic disaster? That is what we need to understand here. The Himalayas are not simply mountains, they are a highly dynamic and geological and hydrological system. The region contains steep slopes, young and fragile geology, high seismicity, glaciers and snowfields, permafrost in some locations, and rapidly flowing rivers. That means a hazard in the Himalayas can trigger another hazard. An earthquake can trigger a landslide. A landslide can block a river. The blockage can create a temporary lake. The sudden failure of the blockade can produce a flash flood. And if heavy rainfall is occurring simultaneously, the consequences can become much more severe. This is the concept we need to understand. Compound or cascading hazards. Let us reconstruct the possible sequence. The disaster occurred around the Bhote Koshi river system. Preliminary satellite analysis indicated that a rock and ice landslide near the Nepal Tibet border may have generated a debris laden flood in the Lende River, which flows into the Bhote Koshi and then the Trishuli. But investigations are still examining the exact trigger. One preliminary explanation suggested that an earthquake may have triggered an ice avalanche or landslide. Another possibility was that a landslide or ice blockage temporarily obstructed the river, allowing water to accumulate behind it. When such a blockage suddenly fails, a very large volume of water can be released almost instantaneously. That is very different from an ordinary river flood. It is a flash flood produced by sudden release. Now comes an important point. We should not automatically say the flood has happened because of a cloudburst. The Indian Meteorological Department specially cautioned against making that conclusion without sufficient rainfall observations from Nepal. The IMD said a western disturbance moving eastward may have contributed to the broader atmospheric conditions over the Himalayan region. But it also stressed that this should be treated as a possible contributing factor, not as the established direct cause of the flood. Meanwhile, the World Meteorological Center in Beijing reported that Nepal had experienced persistent rainfall for around 10 days, with heavy to intense rainfall in some areas, while southern Tibet had also received moderate to heavy rainfall with localized intense precipitation. So, we have a very important analytical distinction. Trigger, what directly release the water. Preconditioning, what made the region more susceptible. Amplification, what made the resulting event more destructive. These are not necessarily the same thing. If we simply call this a flood, we miss the complexity. The event may represent seismic activity leading to ice or snow instability, further leading to landslide or avalanche, then leading to river blockage, then sudden breach leading to flow of debris, followed by a flash flood, resulting in infrastructure destruction. That is a cascading hazard chain. And this idea is becoming increasingly important in disaster management because modern disasters are not caused by a single hazard acting independently nowadays. They emerge when multiple vulnerabilities and hazards interact. There is also another dimension here. The Himalayan region contains enormous quantities of ice and snow. When climate conditions change, the stability of glaciers, ice masses, snowfields, and the frozen slopes can also change. However, we should be careful. We cannot simply attribute a particular disaster to climate change unless the evidence establishes that connection. What we can say is that changing climatic conditions can alter the background environment in which hazards occur. That means disaster preparedness must increasingly consider rainfall plus snow plus ice plus glaciers plus slopes plus rivers plus settlements as an interconnected system. Now, the story becomes particularly important for India. The Bhotekosi River originates in Tibet. It flows into Nepal's Trishuli River, and the river system ultimately enters India as the Gandak. So, a hydrological event that begins in one country can have consequences downstream in another. This is not unique to this particular river. The Himalayan river systems are inherently transboundary in nature. Water originates in the upper Himalayas. It crosses international boundaries. Millions of people downstream depend upon these river systems. Therefore, disaster management cannot always stop at the international boundary. It requires hydrological data sharing, rainfall information, early warnings, real-time communication, and joint disaster preparedness. The current tragedy, therefore, has an important lesson for India-Nepal water cooperation. Imagine authorities in the downstream country know that river discharge is rapidly increasing upstream. They may have hours to evacuate vulnerable populations, but if the information arrives late, those same hours disappear. This is why today's broader India China discussions are also interesting. Following the latest India China special representatives talks, the two sides agreed to maintain communication on sharing hydrological data and to hold another meeting of the expert level mechanism on transboundary rivers. The same principle applies across the Himalayan region. Hydrological data is not merely scientific information, it is a disaster management resource. Now, we come to the second half of the disaster equation. A hazard does not automatically produce a disaster. Disaster risk depends broadly on hazard multiplied by exposure multiplied by vulnerability. A mountain slope may be inherently unstable, but if there are no people or infrastructure below it, the disaster impact may be limited. Now play roads, bridges, hydropower projects, settlements, tourist facilities, and communication infrastructure in vulnerable valleys. The same natural event can then produce catastrophic consequences. The Nepal authorities reported a major damage to roads, bridges, hydropower, and communication infrastructure. That tells us something important. Infrastructure location matters as much as infrastructure strength. This brings us to a difficult policy question. The Himalayas need roads, hydropower, tourism infrastructure, activity, border infrastructure, and economic opportunities. But the Himalayas are also among the world's most hazard sensitive environments. So the question is not should we develop the Himalayas? That is an unrealistic question. The better question is how should development take place in a landscape where the natural baseline risk is exponentially high? This is where risk sensitive infrastructure planning becomes essential. Traditional disaster management often work like this: better hazard, warning, respond, rescue, build. But cascading Himalayan disasters requires something more. We need hazard mapping, multi-hazard assessment and use planning, risk-sensitive infrastructure, real-time monitoring, cross-border data sharing, early warning, evacuation, rapid response. This is a shift from disaster response to disaster risk reduction. India shares long sensitive Himalayan boundaries with Pakistan, China, Nepal, and Bhutan. Several major river systems originate in or pass through the Himalayan region. Therefore, India's disaster vulnerability cannot be separated from events in neighboring countries. For India, the lesson is particularly important in Uttarakhand, Himachal Pradesh, Sikkim, Arunachal Pradesh, and the rest of the northeastern region. The priority should be to strengthen mountain hazard monitoring, landslide monitoring, glacial and snow observation, river level monitoring, weather forecasting, satellite-based assessment, and cross-border information sharing. One of the most interesting aspects of the Nepal disaster is the role played by satellite imagery. Preliminary analysis using Planet Labs satellite imagery helped identify the rock and ice landslide and debris flow mechanism. This shows how disaster management is increasingly becoming a space enabled activity. Satellites can help identify landslides, flood extent, damaged infrastructure, glacier changes, river course changes, inaccessible disaster zones. In mountainous terrain where ground access is difficult, satellite observation becomes particularly vulnerable. There is another important issue here. The Himalayas do not respect political boundaries. Atmospheric systems cross borders. Rivers cross borders. Landslides can affect downstream regions. Glacial processes can have downstream consequences. And therefore, the geography of disaster does not necessarily match the geography of sovereignty. This means that disaster management in the Himalayas increasingly requires regional cooperation. Now we will see how India has responded. India has already responded with humanitarian assistance. The Indian Air Force deployed a C-130J aircraft carrying 10 tons of essential relief and medical supplies with additional aircraft and helicopters earmarked for relief, rescue and evacuation. The Indian embassy in Kathmandu has been coordinating with Nepalese authorities. This is important as an example of humanitarian assistance and disaster relief diplomacy. But we should distinguish between disaster relief and disaster risk reduction. Relief saves lives after the event. Risk reduction attempts to prevent the same level of loss next time. The latter is more strategic objective. So, what are the learnings from this disaster for us? The first lesson is do not look at Himalayan disasters as a single hazard event. Floods may involve landslides. Landslides may involve earthquakes. Ice avalanches may trigger floods. Rainfall may amplify everything. The second lesson is a warning is useful only when it reaches the vulnerable population in time. The third lesson is infrastructure planning must reflect geological and hydrological risk. The fourth is transboundary rivers require transboundary disaster cooperation. And the fifth is climate adaptation must include mountain systems. So the larger question is there is a tendency whenever a disaster occurs to search for a single culprit. Was it climate change? Was it heavy rainfall? Was it an earthquake? Was it a landslide? Was it poor infrastructure? But complex disasters rarely have a single cause. The more useful framework is trigger plus vulnerability plus exposure plus amplification. A natural hazard becomes a catastrophe when it interacts with the human vulnerability. And that is precisely why disaster management cannot merely predict the weather. It has to understand the entire risk system. So, what does the Nepal flash flood really tell us? It tells us that the Himalayan region must be viewed as a single interconnected environmental and disaster risk system, even though it is divided among sovereign countries. The event demonstrates why meteorology must connect with geology, why hydrology must connect with disaster management, why satellite technology must connect with early warning. And finally, why national disaster preparedness must connect with regional cooperation. Most importantly, we must change the way we think about Himalayan disasters. The question is not simply why did the floods happen? The more important question is why did a natural hazard become a catastrophic disaster and what could have been done before it happened? That is the real question of disaster management. And for India, the answer will increasingly depend on our ability to combine science, technology, regional cooperation, climate adaptation, and risk sensitive development. The Himalayas will continue to generate natural hazards. Our challenge is to ensure that those hazards do not automatically become human catastrophes.